All right, let's talk about the freezing and melting lab that we did last Thursday or Friday. First thing I want to talk about is the graph that you should have made. And I'm just going to sketch it. I'll actually put a piece of graph paper on there. What you should have had was time across the bottom with some sort of label, probably 15-second intervals would be the easiest way to do it, but you could have went 0, 15, 30, 45, 60, whatever, and then temperature in degrees Celsius over here, and then give it a title, freezing and melting graph. So what this graph should have looked like, I'm not going to put all the numbers in there. Again, I'm just going to sketch it. It should have started somewhere around 90, and it went down until it got to about 60 degrees, and then it leveled off for a while. And then it went down again until it got to 40. And it probably started to level off a little bit as it got to 40 because it was getting closer to room temperature. So this flat section here, this is the freezing point or melting point. Same thing. And for wax, which is what we used, candle wax, the freezing point or melting point is always the same. It doesn't matter if we're heating it up or cooling it off. Cooling it off gives us a little bit better curve. That's why we did it that way. But it's always about 60 degrees Celsius. Okay? So that's what that flat section means. It's a change in state. So I'm going to erase this. And let's go ahead and talk about the blue questions. Now they wanted you to do water too, but they actually have a graph of that in here that will show you. So let's look at blue question number 1. It says, what was the temperature at which the solid first appeared? It's probably, if you look at the top of the test tube, you're going to get a solid appearing there first, but it probably is between 60 to 70 degrees Celsius. The second one, in your table of temperatures and times, you note any difference in the way the substance and the water cooled? Well, we didn't do the water because it was just going to take too long. But you can see a graph of what they did. And so you can see the candle wax didn't go down in a steady curve. Okay, it kind of bounced around a little bit at its freezing point or melting point here. But with water, we kind of ended up with a steady decrease in temperature. So we're going to say for blue question number 2 is this. No flat line for water. There was no flat line for water because water didn't go through a phase change. It didn't change states. Do all graphs have a flat section? Yes. Does the temperature of the flat section depend on the mass of the cooling material? No. Okay, water melts at 0 degrees Celsius or 32 degrees Fahrenheit. Candle wax melts at around 60 degrees Celsius, no matter how much you have. Now, the more you have, the longer it's going to take, but it's still going to melt at 60 degrees Celsius. Do you think that all the samples used in the class were of the same substance? Some years I changed that. This year I haven't. So yes, they were all the same. Everybody had a flat section at about 60. So let's go on to the questions at the end, 28 through 30. Number 28. It says the graph in figure A represents data from an experiment on the cooling of TOP. TOP is just an abbreviation for some sort of a food preservative. It says during which time interval is there only liquid, only solid, both liquid and solid. So here at the beginning, this is the highest temperature. So letter A is liquid. Letter C is the lowest temperature here. This is when it's a solid. And then letter B, this is where it's going through the phase change. This is where it is both a liquid and a solid. Number 29, water freezes at 0 degrees Celsius. Sketch a graph of temperature as a function of time for a container of water at 20 degrees Celsius after it's placed in a freezer at -10 degrees Celsius. Show the temperature plus 20, 0, and negative 10 on the vertical axis. Continue the graph until practically no further change will take place in the temperature of the ice. So I'm just going to sketch this. So again, we'll put time across the bottom, temp along the side, and the temperatures they want are 0, 20, and negative 10. And so what should happen, because water has a freezing point or a melting point at 0, the temperature is going to go down until it reaches 0, then you're going to have a flat line. And that flat line is going to last until all the water has frozen. Then it's going to go down again until it gets to negative 10, and it's going to flatline again, not because it's freezing or melting, but because this is the temperature of the freezer. This is as low as it can go. So it's not going to go below negative 10. So that's what your graph should look like for number 29. Number 30 says a student uses a home freezer in an experiment to find the freezing point of rubbing alcohol. The temperature reaches a plateau at negative 10, but the alcohol does not freeze. How can you explain this result? I'm going to say the freezing point, FP, of rubbing alcohol is below negative 10 degrees Celsius. It's actually like negative 80 something degrees Celsius. So it's below that, so you're going to reach a flat line, but the rubbing alcohol is not going to get any colder than that. So those are the answers to freezing and melting.